a mysterious wanderer streaking through the cosmic dark. It went behind the sun, now it has reappeared. The interstellar visitor named 3I Atlas has returned, but it's strangely growing brighter.
October 29th, 2025. While most of the world went about their day, telescopes across the planet were locked onto a single point in space. An interstellar visitor was making its closest approach to our sun. And what happened next has scientists questioning everything. Not because it exploded, not because it disappeared, but because it got brighter, much brighter, in ways that don't match our predictions. And now, 72 hours later, the United Nations has done something they've never done before in the history of space observation. They've activated planetary defense protocols for an interstellar object. Let me walk you through what's actually happening. Because the real story isn't what you've been reading in headlines. When 3I Atlas, that's what astronomers are calling this visitor, when it swung past the sun, instruments detected something unexpected. The brightness didn't follow the curve that models predicted. Instead, it spiked. Hard. Faster than the weeks before. Twice as fast, according to observations from Qicheng Zhang at Lowell Observatory and Carl Badams at the Naval Research Laboratory. Now here's what makes that significant. This isn't some random chunk of ice from the outer edges of our solar system. This object has been floating through the galaxy for potentially 7 to 12 billion years. That's 3 times older than Earth. It existed before our sun was born. Think about what that means. Every star it passed, every radiation field it traveled through, every gravitational interaction over billions of years. This thing survived all of it, and now it arrives here and starts behaving in ways we didn't anticipate. The spectral analysis shows why scientists are paying attention. When they break down the light coming from 3I Atlas, it's not just reflected sunlight. The object is actively emitting carbon compounds, water molecules at a rate 40 times higher than a month earlier, like someone turned on a faucet. But there's a problem with that imagery. Comets, they don't work like faucets. They don't have on-off switches. They gradually heat up as they approach the sun, gradually cool down as they leave. Smooth curves, predictable behavior. This isn't that.